Hi everyone, in this video I'm going to talk to you about RMS. I'm hopefully going to explain what RMS is and where you'll see it and why we need it and how it works. So to start with, where will you see RMS and what exactly is it? It's a way of getting voltage or expressing an amount of average voltage in an AC circuit. So what does it stand for to start with? It stands for root, mean and square. RMS, root, mean, square. And of course these are all mathematical functions, if you like. So yeah, root, mean, square. So where will you see stuff about RMS? You'll most likely see it from anything really that relates to AC voltage. So somebody might say, oh, your circuit is 240 volts RMS, or yours is 110 volts RMS, or yours is 220 volts RMS, referring to your AC power probably, or your AC electricity, AC voltage, whatever you want to call it. So that's where you're likely to see or hear about RMS. So like I said before, it's a way of averaging out AC current. So let's take a quick look at an AC wavelength, waveform. So on an oscilloscope you're most likely going to see something that looks a bit like this if you were to measure AC voltage. So it's alternating current and the waves look like that. So it's not DC current where it's a flat line, this is AC. And RMS is only used in AC, it's not used in DC, because in DC it's a lot easier. So the problem is, what voltage is that? How are you going to tell somebody, oh, this AC is this voltage? How can you do it? Because the problem is, here's 0 volts, and you could measure the peak, and the peak may be, say, 325 volts. The trough here could be minus 325 volts. But how would you actually say to somebody, oh, this AC circuit is this amount of voltage? Because these aren't averages, this is the peak and this is the trough. So it wouldn't be a very good idea, it wouldn't be very accurate to just say, oh, the AC current is between minus 325 to plus 325. Although you could do it that way, it wouldn't be very nice, it wouldn't be very useful. So what would be handy is if you could find an average voltage and say, this is this many volts. So how would you find an average voltage for such a situation? Well, of course, like all averages, mathematical averages, what you do is you sample and you find the middle of the sample. And there are different ways, of course. There's the mode, which is the most common. There's the mean, which is all of them divided by the amount of samples, and there's the median, which is the bottom one take away the top one, or there's different things, different ways of doing it. But the most common one that I use is called the mean. But anyway, if I just take, let's say I was going to take a sample there, and a sample here, and a sample here, and here, and here, and here, and here, and I was to take all these samples all the way down here of the wave, or many waves, what would I get? Well, if I just show you over here, let's say here we take a sample here, I'd get 0 volts. And if I say, let's take a sample here, I'd get about 150 volts. Let's take a sample here, we get around about 300 volts. Let's take a sample here and here, we'd get 150 volts and 0 volts. So there's our samples taken from the top of the wave, but of course this is AC, so we need to take this wave into consideration as well. So if we take that wave into consideration, that half of the wave, we will get, we've already got the 0, so then we'd get minus 150, minus 150, then we'd get minus 300 volts, then we'd get minus 150 again, which is here, and then we get 0 again. Now, so up to now what we've done is we've taken an average, or we've taken samples of all of these in the wave. Taken random, equal samples of the wave. And these are the values we've got. Now, if you actually add these together and find the mean, you'd probably be quite surprised. So if we do it, we've got 0 volts and 0 volts. We've got 150 volts and minus 150. So straight away that cancels out as 0 volts. Then we've got 300 and a minus 300, so the average is still 0, because you add them all together, it's 0. Then we've got 150 and minus 150, which is still 0, and then we can add a 0. So the average voltage of an AC wave, or the mean of an AC wave, is 0 volts. And if you were to say to your friend, you know, oh okay, I've measured the average of this these waves, of this AC, and yeah, the average is 0 volts. Well, technically the mean is 0 volts, and that is the average voltage. But of course, that's ridiculous, because if you get another wave, which the wave may be smaller, I mean the peak and the trough may be smaller, the average will still be 0 volts. And of course, that's not useful. It's a waste of time. So, RMS is a way of averaging out all of this in a way that makes sense and a way that's useful. So now I'm going to show you how it actually works, and I'll show you why this name RMS, or root mean square, is of use to us. To start with, of course, it's important to know what root, mean and square actually mean. So, I'll start with square. I mean, probably all of you know what this means, but you know, just to be on the safe side, square. What is square? Square is where you get a number and multiply it by itself. So for example, the square of 2, or 2 squared, is 2 multiplied by 2, which is 4. So 2 squared is 4. So that's what square means. Mean is where you get a lot of samples, you add them all together, and then you divide by the amount of samples. So for example, if I was to get 2 and 2 and 2 and 2, and add them all together, which would be 2, 4, 6, 8, and then I was to divide them by the amount of samples, which is 1, 2, 3, 4, it's 8 divided by 4, and that would equal 2. So the mean of 2, 2, 2 and 2 is 2. So it's an averaging mechanism, if you like. And root is a number which multiplies by another same number to make another value. So for example, the root of let's say 9. The root of 9. Well, if you get 3 and multiply it by 3, it equals 9. So the root of 9 is 3. 3 multiplied by 3 equals 9. And the symbol for that is something like this. I'm actually no maths expert, but I know it's something like that. The symbol for a square is you put a little 2 above the number. So for example, you put a 2 and it means square. So yeah, they're the basics. Now, so how do we actually do this RMS? Does it work? How does it work? Let's carry on. Okay, so let's look at our drawing again, and we'll approach the averaging in a different way now. We'll approach it in the RMS way. So let's draw our waveform again, or our wave, or whatever you want to call it. Let's go for another one. So there are 2 waves. Now, we need to do the sampling again, but this time we're going to do it different. So RMS, root mean square. Now, I know it's kind of weird, but if we just reverse that and say SMR, instead of root mean square, we say square mean root, or SMR. This is the way you actually prepare the value. Now, if we had to take some samples, let's say we take a sample, let's say we take a sample here, so that's 0 volts, and we take a sample here, so that's let's say 150 volts, and we take a sample at the top, which happens to be the peak, we say 300 volts, then we take a sample here, that would be 150 volts, then we take a sample here, which will be 0 volts again, then we take a sample here, which is minus 150, and we take a sample here, which would be minus 300, then we take a sample here, which would be minus 150 again, and then we take a final sample there, which will be 0. Now we've already tried the mean before, which would, this here, mean, we've already tried the mean, but we're not going to do that this time. We're going to do square mean root. So we're going to do square. So what is 0 squared? Well, 0 multiplied by 0 is 0. Okay, what's 150 multiplied by 150? Well, I'll just get my calculator up. But 150 multiplied by 150 is, or you could just use your square button actually on your calculator, is 22,500. And this looks a bit ridiculous at the moment, but just bear with me. Now I'll just use a calculator. 300 squared, and it is 90,000. And then we've got 150 squared again, which is 22500. And then we've got 0 squared is 0. Right, now at this point I'll stop. So do you remember before when I said we had the values and the lower ones simply cancelled the higher ones out? So the negative numbers simply cancelled the higher ones out, and therefore we wasted our time in trying to get an average of the AC waveform, if you like, or the AC voltage. Now something special happens with this now. So if we get minus 150 and we square it, a minus number squared equals a plus number. So if you get your calculator now and just type in minus 150 and press enter and then square that, you'll see that it's the same as this value here. So I've just pressed square and it's 22,500. So it changes a minus number into a plus number. And of course this will be the same, so that's 90,000. This will be the same, 22,500. And of course 0. So we've now squared. We've done this bit of the calculation. And now what we have to do is mean. So we have to get the mean of this. So if you were to get that, so add these all together, so you get the sum basically, add that, and that together. So I'll just do this on the calculator. That equals 270,000. 270,000. Now, when you're doing the mean, of course you do have to take into consideration all of the samples. So how many samples? 1, 2, 3, 4, 5, 6, 7, 8, 9 samples. So even though it's 0, it's still a sample. So if we get 270,000 now and divide that by 9, so I'll just do this on my calculator, divide by 9 equals 30,000. So 30,000, and again this looks ridiculous at the moment, it looks completely meaningless. But now if I was to get, well, there we go, so we've got the mean actually, so that's the mean number. Now if I was to root this or find the root of 30,000, that will tell us the average voltage. So now let me just fill in a few areas here. So we said that this was 300 volts here, and we said that was the peak by the way, and we said the trough was minus 300, and this of course will be 0 volts. Now this here, this SMR, will give us the RMS of this this waveform. So if I just get my calculator up, I'll get 30,000 and square root, and it says the voltage is 173 volts. So the RMS is RMS 173 volts AC. We do have the RMS value now. That's how to work out the RMS value. However, there is one very important thing. The amount of samples I took here was only 9 samples, and there are potentially hundreds of different values here, all the way across here and all the way back down. And to be able to get an accurate RMS, it depends on the amount of samples you take. So if I take a sample there, and there, and there, and there, and there, and there, all the way across here, I'm going to get a more accurate result. And the more accurate result in this case would be a higher voltage. But the reason it's like this is because at the moment I have 3 samples of 0 volts. So yeah, I've got an unproportional amount of 0 volts samples. So if you get more samples throughout here, you'll get a better result. Now, I don't know how many results you're supposed to sample. Maybe there's a standard for this, I don't really know. But anyway, I kept it simple just to show you how it works. Now, there's actually another way of doing this as well, a much simpler way, but again, it's not 100% accurate. Right, so this other way to calculate RMS. Now, technically, it's not a way to calculate RMS because no root is found, nothing squared, and there's no mean average taken. So it's technically not RMS. However, it gives results which closely resemble the results which RMS would give you. And I'll show you how to do this now. It's really, really simple. So if we have a wave again, I'll just draw one wave. This here is the peak, and this is the trough. Now if you can find the peak voltage, which let's say the peak is 325 volts, as I believe it is in the UK, with that peak voltage you can use this second method in order to calculate something like the RMS. And this way is very simple. You get the peak voltage, so let's say peak voltage multiplied by 0.707. So if I just test this out, 325 multiplied by 0.707, I'll just get this on a calculator. 325 multiplied by 0.707 equals 229.775, which is 230 volts, which is about right. So yeah, that's the proper way how to calculate RMS, and this is just a way of cheating, if you like, a way of quickly calculating an equivalent to RMS. Anyway, I hope you enjoyed the video, and thank you for watching. Bye!